Hi everyone. In this video, I'm going to go over how to find the equation of a line. Now, the equation of a line is given by y is equal to mx plus b. M stands for the slope or the rate of change, and b stands for the y-intercept or the initial value. The two things we need to find the equation of a line are the rate of change and the initial value. Here, we want to find the equation of this line. Now remember, the two things we need to find the equation of this line are the rate of change and the initial value. Remember, to find the rate of change, all we need to do is we're just going to use our formula, rise over run. And to find that here, we need to pick 2 points on this line. And it doesn't matter which 2 points I pick. I can pick any 2 points on this line. So I'm going to pick these 2 points. Now I'm going to draw a triangle connecting these 2 points. And now I can find my rate of change. So my rise is how much this goes up by, how much my line goes up by here. Well, let's see. If you count here, each one of these small boxes goes up by 10, right? Because if you go up 5 boxes, that gives you $50. So each one of these small boxes goes up by 10 here. And now if we count, this line is going to go up by 10, 20, $30. So you can see the rise here is going to be 30. The run tells you how much this line goes to the right. And we can see this is going to go right 2 games. 2 games. To find the rate of change, we're just going to divide these two values, the rise divided by the run. So we're going to take 30 and divide that by 2. 30 divided by 2, that gives you 15. The initial value, to find the initial value, that's just where the line starts on my graph here. And I can tell my line is going to start at $20, right? So my initial value is just going to be 20 here. And now I have enough information to find the equation of a line. Because remember, the equation of a line is given by this form. Y is equal to mx plus b. M, our rate of change, we know is 15. Right, so in place of m, I can plug in 15. So I'm going to do that. In place of m here, I'm going to plug in 15. And b, our initial value, we know is just 20. So in place of b here, I'm going to plug in 20. And there's my equation. Now, sometimes when people write the equation of a line, they might use different letters to represent x and y. Right? So don't be alarmed if you see different letters used for x and y here. So we can see in this graph here, the y-axis, the y represents cost. So we could also use the letter C here to represent cost. And really, we could use any letter to represent the cost here. It doesn't have to be y. Or x here represents the number of games. So we could use n here to represent the number of games. So as you can see, we don't have to use y and x, so you might see different letters. But just to summarize, the two things we need to find the equational line, we need the rate of change and we need the initial value. Let's take a look at a couple other examples. So in this case, I want to find the equation of this line. So again, we're going to find the rate of change and the initial value, and that's going to tell me the equation of this line. To find the rate of change, remember, we're just going to pick 2 points on the line. And it doesn't matter which 2 points we pick. The rise, well, here we're going up by 10, 20, $20. And the run, we're going to the right by 2 days. So the rate of change is just going to be rise over run, 20 divided by 2. So let's do that. 20 divided by 2, that gives me 10. My initial value is just going to be where my line starts. And I can see here, my line starts at $50. So my initial value here is just 50. And now my equation is just going to be in the form y is equal to mx plus b. M is our rate of change. So in place of m, we can just put in 10. And b is our initial value. So in place of b here, we can put in 50. And there we go. And again, just like before, we can use different letters to represent y and x here. Because here we can see our y-axis represents cost. So I could also use the letter C to represent y. And x represents the number of days. So I could also use the letter N to represent the number of days. So here is our equation. Let's take a look at one more example. To find the equational line, again, we need the rate of change and the initial value. So let's start with the rate of change here. Again, I'm just going to pick 2 points on this line. I connect these lines with a triangle. And now let's look. The rise, well, we can see this line goes up to, well, between the value right in the middle, between 200 and 400. That's 300. So I can tell my rise is going to be 300 kilometers. My run, how much this goes to the right, is 4 hours. So to find the rate of change, we're just going to divide those two values. And 300 divided by 4, that's just 75. Our initial value, well, in this case, my graph starts right here at the very bottom left. So here it's going to start at 0, right? Because it starts at the very beginning. And now the equational line, again, I'm just going to plug it in. I'm just going to plug these values into my equation. So my rate of change, my m, is going to be 75. So in place of m, I'm going to plug in 75. And in place of b, I have 0. So in place of my b value, I'm going to put in 0. Now, we know if we add 0 to any number, that just gives us that number back. Right? So say 5 plus 0, that's just 5. 6 plus 0, that's just 6. 7 plus 0, that's just 7. So that stands to reason, if we add 0 to 75x, that just gives me 75x. So I can leave my equation in this form. And if I want, I can change my letters, right? So because we know that y here, my y-axis represents the distance, so I can use the letter d to represent distance, and my x here represents time. So I can use the letter t to represent time. And there we go. This is the equation of my line.